Lesson 6.3, Medians and Altitudes of Triangles. Essential question, can I use medians to find the centroid of a triangle? Can I use altitudes to find the orthocenter of a triangle? Median of a triangle is a segment from a vertex to the midpoint of the opposite side. So here's an example of a median right here. You have to have the midpoint and you have to have a connection from the vertex to that midpoint. Okay, now let's take a look at this midpoint, and this is also a midpoint, and this is also a midpoint. These are all created by the perpendicular bisector. When we connect the vertex to that midpoint, this blue line is called a median. When we connect the vertex to the midpoint, that's called a median. Vertex to the midpoint we call the median. So the three blue line segments are all called medians. Median, median, and median. Now these medians all meet at one point. This is a point of concurrency, and we call it a centroid. The centroid theorem. The centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. So here is the centroid. It's created by all the medians, and what it's saying is that this is 2/3 of the way, then that means this will be 1/3 of the way. So this ends up being 2/3 of the way to the midpoint. All right, let's practice. So this is a centroid. It's created by all the medians, and this is 2/3 of the way. This will be 1/3 of the way. So they want us to find QW. Now 1/3 of the way is half of this, so that number will be 4. So this length is 4. So 2/3 of the way, 1/3 of the way. It's a 2-to-1 ratio. So SW will be equal to 12. All right, let's take a look at a coordinate axis here, and we are going to try to find the centroid. We want to be able to find the point that's 2/3 of the way down. So I think the easiest way we have to find a midpoint. So to find the midpoint of RT. So from here to here we're going to find the midpoint, and that's going to be 2 plus 8 over 2 and 1 plus 3 over 2. So that's going to be 5, 2. 5, 2 is right here. Here's our midpoint. Now we're going to create the median, which is going to be just a line going straight down. And we want to find the centroid, we'll call it P, and it's going to be 2/3 of the way down. Okay, so we want to find 2/3 of the way down, 2/3 from S to M. Okay, sounds like a directed line segment, something we've been doing quite a bit. Let me show you the next screen and remind you how to do that. All right, so we want to take a look at the X change right here, and we know that we want to do 2/3 from point S to point M. Now from point S to point M, that's a distance of, you're starting here at 8 and you're going here to 2, so you're going to go down 6 units. So 2/3 of -6 is -4. So in other words, you want to go down -4 from that. Now here we're starting at S, and here are my coordinates for S, 5 and 8. I don't want to go anywhere in the x-axis, left or right, but I do want to go down 4 units. And when I go down 4 units, I'm right here at 5, 4. So this is the point 5, 4. This is 2/3 of the way down. All right, let's take a look at this. This is also a centroid, and we want to figure out these paths. So SC right here, let me put it in a different color. SC, this whole length right here, is 2,100 feet. And we want to figure out PS, and we'd like to figure out PC. Now remember, this is 2/3 of the way, this is 1/3 of the way. So let's take and divide 3 into 2,100, and that'll be 700. So 1/3 of the way is going to be 1/3 of 2100 is 700. So this length right here, which is PS, is going to be 700, and then PC will be double that, 1400. Okay, now let's take a look at TC and BC when BT is 1000. So let me take a different color. So here it is, BT is 1000. Now remember, these are created by medians, and medians are midpoints. So that means this other side will be 100. So TC will be 1000. I'm sorry, I was saying 100 when I should have said 1000. And BC, that means all the way across, will be 2000. Okay, last one, PA and TA when PT is 800 feet. So I'm going to choose a different color. PT is 800 feet. That is 1/3 of the way. So 2/3 of the way will be double that. That's 1600. So this will be 1600. And then all the way across will be 3200. All right, let's go ahead and find the coordinates of the centroid. And I've kind of got you started. I'd like you to stop the screencast. I've already found the midpoint here, and I'd like you to figure out what 2/3 of the way down will be. And here's the answer. 2/3 of the way down, we have to go down -6. We want 2/3 of -6, which is -4, which will get me to, I'm not moving anywhere left or right, it'll get me down to 4, 5. Okay, here's another one. Less hints now. Stop the screencast. See if you can do that. My only hint is to find the midpoint of XY. That would be the most advantageous. And here's the answer. Okay, well, you need to find the midpoint, and then you take 2/3 of the X change, which is 4. So from Z, you want to travel up 4 units, because that's 2/3 of the way, and you'll be at -1, 2. Okay, the interesting thing about the centroid is it's the center of gravity. So if you were to put a pencil underneath a cardboard, a triangular cardboard, you would have, the forces would balance. And there's a young man balancing it on his finger right now. Okay, the next vocabulary word is altitude. Altitude is the perpendicular segment from the vertex to the opposite side. The key is that it must be from vertex to the opposite side. And of course, altitudes can occur outside the triangle as well. The orthocenter is a point of concurrency for all the altitudes. So if you draw them all, they all meet at one point, and that's called the orthocenter. Let's take a look at finding the orthocenter for this point. Now, I'm going to find one altitude right now. It's easy for me to find this altitude, and that's this one going from here to here. That's an altitude. It is from the vertex, and it's perpendicular to the opposite side. So that's one of them. I just have to find one more. Now, I need to take this and I need to make it perpendicular to the opposite side. Now, the key is knowing the slope of this one, knowing the slope of YZ. Now, you might be able to just read off, it's actually -1. If you need to figure it out, you can go ahead and do that. So this is a slope of -1. That means the line that I want to make has to be a slope of 1. So I'm going to start here at X, and I'm going to go slope of 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And then I'm going to draw my line. And there's my altitude. I know that is the opposite reciprocal. And here is my other perpendicular. Now where they both meet, that looks like it's -2, 2. And that is what we call the orthocenter. It's where all the diagonals meet. And I think I did it right here too by showing the slopes. Okay, here's another triangle. Then we're trying to find the orthocenter. And we also want to discover if it's inside on or outside the triangle. All right, so I'm going to find the find the altitude from point C. So I'm going to go ahead and draw it. And it's going to be right here. I know that this point it has to be perpendicular to the extension of the side, and that'll be making a right angle right here. Okay, and now I want to find one more, so I'm going to want to find a altitude from here to this side. Now I can see this slope is -1, that's what I figured out already. So I know from B to this line I want a slope of +1. So up 1 over 1, up 1 over 1, up 1 over 1, and then I want to go ahead and draw my line. And when I draw my line, the altitudes all meet right here at this point, and this is the point -1, -3, and that's going to be my orthocenter, and it happens to be outside of the triangle. And here I've drawn it again. Okay, your turn. You draw it and you figure out whether it's inside on or outside the triangle. And here's the answer. I didn't have to do much drawing because it occurred right here on the triangle. This is an altitude and this is an altitude. Actually, in a right triangle, the sides are altitudes. So in summary, the orthocenter can occur inside the triangle, it can occur on the triangle, and it occur outside the triangle. One more thing to cover in this lesson, and that's the property of isosceles triangles. Isosceles triangles are quite fascinating. They have a lot of properties. Here's an isosceles triangle, and if I were to draw a median, that means it goes to the midpoint. So this is a median. So the first thing is that this line is a median. If you make the triangles congruent, SSS is the way to do it, then you're going to get this angle congruent to this angle. And since they both add up to 180 and they're congruent, it forces them to be perpendicular. So not only is this a median, but this can also be called an altitude. And since the triangles are congruent, these angles are congruent, so it can also be called an angle bisector. So this one segment right here plays the part of 3: altitude, angle bisector, and median. Here's a summary of what we've been learning: the 4 points of concurrency and the 3 vocabulary words of the segments that form them.